That's 2, 3. Now, the other question is for you to find or build the new Dijkstra shortest path tree. Now, we need to build a tree because this was the original uh, uh, network or nested network that you had to maneuver your way, that the Dijkstra algorithm would have to maneuver its way to identify the least cost. Now that it's identified the least cost based off the table, we have to come up with a new uh, tree path for it that will reflect the shortest path that we have. So to do that, what I usually do is use my diagram application. Of my diagram application and then start sketching is it open? Okay, so this is the diagram application, and then we're going to reference our new tree uh, based of this tabulation. Okay, so looking at it carefully, let's call our routers. Uh, okay. So we have, so I'm going to go back to the diagram and look at it carefully. Trying to recreate that diagram. Yeah, so I'm basically just redrawing all uh, the routers, or putting back the network again all over. These are the nodes that we have. This is a node of R10 is right over here. R7 is R7 is down here, and then R4 is down here. Okay, so we have all 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all 10, more or less trying to mimic this. But now the tree wouldn't look as complicated with all the back and forth path and the least cost anymore. Let's try to label the, so this was R1 where the customer was connected to. This was R2. And this was R3, R3. This was R4 here. R4. This was R6, right? R6, 3, 4. This is 5 here. And there was 8 right after it. And then we had 9 over here. 9, and then up 10 down here. I think 7 was down here as well. Oh, 7. Alright, 7. Okay, so we got them all labeled up, similar to what we had over here, original design. Okay, so now let's go with the Dijkstra tabulation to figure out the shortest path. So from R1 to R2, it was 1. So it was from here, and the cost was 1. So it was that right there from the first iteration with router 1 as the only option you have to get 2. So that was 1. For 3, for router 3, it was 3 metrics, and which was from let me see, let's go to the table, which was using 1 and 2. So you had it was from 1 to 2 to 3. So the cost was 2 here. Oh, sorry. Uh, so it was supposed to be 2. Okay. Oh, let's put it back again. It was 2. Okay. So 1 plus 2 gave us a 3. A 3 here, which was going through using 1 and 2 as an iteration. As your iteration notes, so we had 1 plus 2. That's how I got a 3. For 4, it was direct. And what was the cost? It was 2 instantly. What about 5? 5 was at a metric a list cost of 2, and we actually had to go through 1 and 2. So if you had 1 over here, then there must have been 1 over here to add up to the 2. Is that right? Yep, that's right. Okay. What about, so that was 5. What about 6? 6 had its least cost metric when we had how many nodes to work with? At the sixth iteration with 1, 2, 3, 4, 5, and 7. So we had one, we had to go through one. We had 6 options to get the 4 least cost metric to get to 6. Okay, and it was, if I'm not mistaken, it came from going from 1 to 3 to 1 to 2 to 3 to 6. Yes, it was supposed to be what's the cost again? It was 4, right? Is that 4? So it's 1 plus 2 plus 2. Yeah, no, that's not a route. It was um oh, so it was from here. It was using going through 7 routes. So it was from 1 to 4 to 7 to 6, which was 2 plus 1 plus 1. That was the 4. So in other words, we would have to go from 1 to 4 to 7 to 6. And since it was 4, that means each has to be 1 1 each. So come back and do the labeling for that. So it was 1 here and 1 here. So that's how we got the 4 we had. So it was 2 plus 1 plus 1. Oh, this arrow is wrong. It's supposed to go this way. Okay, so now what's next? For 7, it was 3, and that's when we had 1, 2, and 4. So we're going to 1, 2, and 4 to get to what? 7, right? But the list cost was just right over there. It was already established from the previous 4 6 hour 6 initialization. So that's already established for you. That's from 1 to 4 to 7. 3 count, right? 3 count was going through 1, 2, and 4 option. 1, 2, and 4 option to get to 7. But the least cost was from R1 to R4 to get to R7. So that's a 3, 2 plus 1. Okay, so that's great. For 8, it was when we had 1, 2, 4, and 5. So 1, 2, 4, and 5. 1, 2, 4, and 5. And to get to 8, the shortest was going by 1, 2, 5 to 8. And you had 4. So if you had 4, it means this must have been 2 because it's 1, 1 over here already. Let's go through and see if it's correct. That's correct. So you got 1, 1 plus 2, 4. So we label that to be 2. Okay, so now what about 9 and 10? 9 had 7 when we were using what? How many iterations? 7 iterations. 1, 2, 3, 4, 5, 6, 7. Okay, and I think the shortest path, because that's 7, was when we had to go through, let me see, 1, 2, 4 plus 3. So it was going through this route. So it means there was, if we already have 4, then this was must be 3 to add up to the 7. So that would have a value of 3. So 1 plus 2, 2 plus 2, 4, 4 plus 3, 7, which is the 7 we have over here. Now for the last one, 10, it was 4 when we had 6 iteration. I think it was coming from, so what was the number? It was 4, right? So it was coming from from R1 to R4 to R7 to R10. So that means this must have been 1 to get the 4 because you already have 3 cost already. So this is 1. So that should do it. We've covered all of our 10 nodes. So this will be the new, so this is what I usually do. So you can save this as an image, export as an image, and save it somewhere in on our desktop. So we can name it shortest path, tree. Save, and then we can go back to our and then insert an image or say a picture from our desktop. This was it. Much better. That's it. So this would be our new Dijkstra shortest path tree that was generated from the tabulated execution of the Dijkstra algorithm. So if you look at the new shortest path 3, it's not as complicated or nested like the original network is. It's much more simplified, you know. Are we good? Okay, so after that, the